Hello everybody, this is lecture 3, Zealously Physics. Before starting, I request you to like, comment and share and subscribe the channel. Ohm's Law, George Simon Ohm. Ohm's Law gives relation between two electric quantities. Cell is connected, it's positive and negative terminal, one battery is connected with the potential difference V. Current starts flowing. Now two batteries are connected. The positive and negative terminals are shown. Potential difference is V. Current I starts flowing. Now instead three batteries are connected. The positive and negative terminals are shown. Current I. You see current is flowing. So more current flows and the bulb is lighted. See, Ohm's law states that current I flowing through a metallic conductor is directly proportional to the potential difference V across its ends provided its temperature remains the same. Length, area of cross section, temperature, material, these are the physical quantities. They should remain constant while obeying Ohm's law. V proportional to I, V by I is equal to R. It's constant, we call it constant V by I. That constant we call R as resistance. So V is equal to I multiplied by R, hence V is equal to IR. This is known as Ohm's law. Now resistance. The conductor, same conductor is connected with a battery. When atoms are more, resistance is more. And current is less. When atoms are less, resistance is less. Current is more. The property of the conductor due to which it opposes flow of current is called resistance. The SI unit of resistance R is ohm, omega ohm. R is equal to V by I. Ohm is equal to volt divided by ampere. The potential difference across two ends of the conductor is 1 volt and the current through it is 1 ampere. Then the resistance of the conductor is 1 ohm. Factors affecting resistance: length, area of cross section, and the material of the conductor. Also temperature. Now see R proportional to L. So take a conductor, so increase the length, so resistance is more. Now R inversely proportional to the area of cross section. The factors affecting resistance: if the door is wider, more people can enter, so resistance is less. If wire is thicker, more electrons can flow as resistance is less. Hence R proportional to 1 by A, or resistance is inversely proportional to the area of cross section of the conductor. Therefore R proportional to L by A. So R is equal to constant L by A, so we call this constant as rho, RH or rho. Unit of resistivity or rho, we call rho as resistivity. So unit of resistivity, R is equal to rho L by A. Therefore rho is equal to RA by L. So in place of resistance I put omega meter square in place of area, and meter in place of length. So meter square, meter cancels. So SI unit of resistivity is ohm meter of omega meter. Practical understanding of resistivity. Electric circuit is provided, the ammeter connected, the battery is there, this is the ammeter circuit, and here the key is provided. Two terminals A and B is open. Now it is connected with the copper wire. You see the reading of the ammeter. Now when it is open, no current flows. Now aluminum wire is put and see the current strength decreases. The reading of the ammeter is less than the previous one. In copper, the ammeter reading is more, and here in for aluminum, the ammeter reading is less. Now I put glass rod and see no current flows, ammeter reading is 0. Rubber in place of glass rod, so no current flows. So resistivity is a specific property of a material. Different materials have different resistivity. It's fixed. You cannot change the resistivity. You can change the resistance because with the length and the area of cross section, but resistivity is a specific property. It is constant for every material. Now question number 1. On what factors does the resistance of a conductor depend? What factors rather? The resistance of a conductor depends on its number 1 length, number 2 area of cross section or thickness, number 3 material, number 4 temperature. Number 2, question number 2. How does the resistance of a wire change when its length is tripled, its diameter is tripled, its material is changed to 1 whose resistivity is 3 times? Answer: R is equal to rho L by A. So for the answer of question number A, 2A, R proportional to L, if L is tripled, the resistance is also tripled. If the length is tripled, the resistance is also tripled. Now B, R proportional to 1 by A, or R proportional to 1 by D square. So area pi D square, pi D square by 4 or pi R square. Therefore, if the diameter is tripled, resistance becomes 1 by 9 times. Now part C, R directly proportional to the resistivity of a conductor. If the resistance is tripled, its resistance is also tripled. Question number 3, will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Why? Answer: when connected to a same source, current will flow more easily through the thick wire than the thin wire. Number 2, resistance R directly proportional to 1 by A. Thank you very much. Hope you have enjoyed the video.